Hello, and welcome to a sneak peek at my most recent project, Project Dragon. In this video, I'll be explaining a little bit about the project and the systems I currently have implemented. Keep in mind that this project is still in development, so things may change from how they are currently. This project is a point-and-click style adventure RPG set in a medieval time that was influenced by games such as Diablo 2 and Dark Souls. But enough about the details, let me hop into a new game and show you around. You play as Sir Buddington III, an older adventurer who has just arrived at Newtown. Because this game is point-and-click, this game relies heavily on raycasting and sphere casting to move and interact with objects, NPCs, and items on the ground. Speaking of which, there's an NPC nearby. Let's see what he has to say. To handle the dialogue between NPCs and the player character, I built a custom dialogue editor scene view where the dialogue as a whole is a scriptable object, and each node in the tree is a scriptable object that is then childed to the main dialogue scriptable object. The dialogue editor allows a designer to easily create dialogue trees, determine whether the player or NPC is speaking, the conditions on which that dialogue node will appear to the player, which nodes are childed to the current selected node, child and unchild linked nodes, add or remove dialogue nodes from the tree, and any actions that will happen when entering or exiting a specific node. Let me show you what I mean. Let's take a look at my quest giver dialog tree. If we double click on it, you'll see it brings us right to my dialog editor, which is where we can easily see the dialog tree I have set up. We can also see in the inspector all the nodes that are linked to this specific dialog scriptable object. The gray nodes indicate that the NPC is the one speaking, whereas the blue nodes are the player. This can be easily changed by checking the Is Player Speaking checkbox on the right. If we move down the tree a little, you can see in the inspector that this dialog node has conditions attached to it. This means this dialog will only appear when these conditions are met. Finally, if we go to the end of the dialog tree where the player accepts the quest, we see that this node has an on-exit action. This means that once this dialog box is finished, the action Give Quest will happen. Now that we know how the dialog works, let's talk to some NPCs and get assigned our first quest. Great! We've been given our first quest. In order to view quests that the player is currently on, I'll press Q to toggle my Quests tab. This piece of UI shows the player their current quest and how far along they are on it. In order to view more details about the quest, the player just needs to hover over the quest they are curious about. Doing so spawns a UI tooltip that shows the quest's current objectives and rewards for completing the quest. Let's work on completing that first objective. In order to level up one's strength, they need to add attributes to their strength modifier. To do so, we press T to bring up the trait menu. This shows what our current traits look like, and we start with 3 points to assign. As it stands so far, leveling up strength grants you more damage per hit, constitution gives you more max HP, intelligence increases your max mana and your mana regen rate, and charisma increases the discount you receive in shops. Dexterity will increase movement and attack speed, but I have yet to implement that. Let's start by increasing our strength so we can do more damage. Confirming allocation saves those points into their respective scores and cannot currently be undone. Now that we are a bit stronger, let's go into the town and see if we can find some guards or a shop of some sort. This game's shop and inventory system work hand in hand, so I'll show them to you at the same time. Pressing I opens the player's inventory, where we can see 2 new pieces of UI. On the right, we have the player's bag, where all the items they pick up or buy are placed. On the left is the player's equipment tab, where they can equip weapons or armor they find along the way. Finally, the bar on the bottom is the action bar, where potions and ability scrolls can be kept and used. Items in the inventory can be dragged between inventory sections, will swap spots in the inventory if dropped on a different item in the inventory, and will return to the inventory if placed in a proper location. They can also be dropped on the ground around the player in a random fashion. My shop system is very designer-friendly. It is a script on the player designating them as a shopper, and a shop script that is put on every shopkeep. On the shop script, the designer can name the shop, enter a selling percentage for buying back items, and an initial buying discount percent that can be increased or decreased. It also has the stock config, which is where all the shop's items are handled. Let me show you an example. Let's add a fireball item to this shop. We can add a new slot, find the fireball scriptable object, and assign it to this slot. Then we just have to set the initial stock, any additional buying discount percentage for this specific item, and what level the player needs to be for this to appear in the shop. Now, if we go to the shop, we can see that there is a fireball for sale, there is 5 in stock, and its initial price was 100, so we can see that the discount is working. When we open the shop, we can see the inventory the shopkeep has. We also have filters along the top that can help us navigate to items we're looking for. The shop is tiny, so we don't need to worry about that much right now, but this is how those filters look. Let's start by buying a wooden dagger and a few health potions. You can see as we add items to the quantity, the total goes up. If the total is higher than our gold amount, we are unable to buy items in the shop. This also happens if the items we would buy would be too many for our inventory to hold. Once we select the things we want, we can confirm the purchase, and now these items have moved to our inventory. We can equip the dagger and move the health potions down to our action bar for quick use. Now we're ready to fight some guards. I'm going to let this play out in the background as I continue to explain other features and functions I added to the game, starting with how I have items set up in this game. I have all my weapons, equipment, and abilities set up as scriptable objects that are also menu assets. All of these things go down a line of inheritance within the scripts, inheriting from an equipable item script, which inherits from an inventory item, which inherits from a scriptable object script. Doing this enables me to very quickly make new versions of items simply by inheriting from the correct spot in this line of inheritance. Right-clicking in my asset folder, I can quickly find these scriptable objects, choose what I want to make, and make a new scriptable object of that type. I won't make a new one now, but let's look at a couple different items I have made as an example. The wooden dagger, a healthy hat, and my super mega splash ability. Because of inheritance, you'll see that while all these items are made using different scripts and have different functions, they all have many of the same options when looking at the item details. Every item has a unique item ID, an option for display name and description, an icon, a pickup prefab, a stack ability, a buy price, and its shop category. Then comes the item-specific details depending on what the actual item is. Out of the 3 that I've showed you, I want to explain the Super Mega Splash ability a little more in depth. Every ability has a targeting strategy, which is how to aim it, a filtering strategy, what it will hit, and an effect strategy, what it will do. These are all different scriptable objects from scripts that inherit from a targeting script, an effect script, and a filter script respectively. This allows me to create a near infinite amount of abilities that have different effects, targets, and filters, and they only require a couple lines of code to make. Now let's move on to our antagonists of the game. All of my characters in the game come from prefab variants of a base character class. My enemies best show use of this as I have 6 instances of different enemies that all derive from one base enemy which derives from this character base class. The enemy's AI is set up to stay in a patrol behavior until the player either attacks them or enters into their chase distance. In a patrol behavior, the enemies can either be standing idle or follow a simple patrol path using a path prefab I've made with simple waypoints. If the player attacks a guard or enters their chase distance, the guard becomes aggravated and enters an attack behavior. While in attack behavior, a guard will go to the last known point of the player, alert other guards that are within its shout distance, triggering their attack behavior, and if they get in range of the player, they will attack. If the player manages to run away in an attempt to hide, the aggravated guards will chase for an editable period of time, then give up and return to their initial patrol behavior. In order to handle the interaction between movement and attacking with both player and enemies, I implemented an interface I called iAction. This interface helps manage the communication between my movement script and my fighter script by canceling the previous action if a new action is called. For example, if I'm moving and then click an enemy to attack, iAction cancels my movement function, calls my attack function, and this can work vice versa. This is not the only time I use an interface in this project, but this is probably the most predominant use of one. I also use interfaces to handle actions between adding, removing, and dragging items in the player's inventory and shopkeeper stores. I also implemented an interface to handle modifiers to the player's stats from things like equipment and abilities. And finally, other interfaces handle interaction with my raycasting, saving system, and predicate evaluation for quest, dialogue, and item conditions. The final thing I want to touch on in this project is the save system I have set up in the game. I built this save system from the ground up, and it relies on any savable entity or object having a universally unique identifier, or UUID for short. which it uses to save that entity or object to a scriptable folder on the player's disk. A savable entity script is attached to any parent object that contains data of any sort that I want to have saved between scenes and plays. Saving and loading of any particular object is done using an iSavable interface, which has a function to capture that object's current state in a dictionary, and a function called restoreState, which is used to restore the captured state from a dictionary. Finally, in order to save things like vector3s, I made a script which acts as a serializable vector3, which allows me to save those values because Unity doesn't save vector3s by default. I know that I've been talking for a while now, and there are still many things I could touch on in this project, such as the player and enemy's progression as the player levels up, how I set up a drop library to calculate the rate that enemies drop items and what kind of items are dropped. But because this is just a quick vertical slice of this project, and both of these are currently not being used to the extent that I'm planning to use them, I'm going to spare you the details on those and just give you a quick peek on the scriptable objects that implement these two features so you can get a bit of a feel for it. I hope you've enjoyed the sneak peek at the inner workings of my project and how it looks so far. If you have any questions or suggestions on things to add, please leave them down in the comments below, as I'm always looking to improve on my work. Thank you for watching, and I hope you have a great day.